There's a legality volume that states how far above the roof of the car you can go with the rear wing, how far rearwards of the rear bar you can go. And the biggest thing is the downforce and cornering, because in cornering condition, the uncontrolled flow in the center of the car has a tendency to move around a lot more. In the straight line, you can actually control it all right. But the second you get into a corner, it likes to move all over the place. And that's where a flat floor would be much better.
Being competitive at World Time Attack requires aerodynamics, but it's not just a case of bolting on an aftermarket wing and hoping for the best. We're here with Kyle from JKF Aero to talk a little bit about how development of an aero kit works. So for a start, Kyle, this car behind us, can you talk to us a little bit about how you've been involved with the development of the aerodynamic package?
Yep. So basically with this car, I am the main aerodynamicist on this current package. It started with Nick seeing me about a year ago or so, where he wanted some work on his front duct work for last year's Time Attack. And so we did that. That worked out great. And so then he decided he wanted to move from a more basic aero kit into something a little bit more complex, a little bit more bespoke, particularly dealing with the new Pro Open rules that were coming out. So we worked together on this package over here.
Okay, can you talk to us about the rule set? So you mentioned new Pro Open rules, and I guess more specifically, how you as an aerodynamicist read the rule book and kind of interpret how you can maximize the aerodynamic package and still be legal.
Yeah, so with the Pro Open rules, basically they split up open class into normal open and Pro Open. Pro Open is very similar rules to normal open. You still have an exposed floor between the axles and center line. There's slightly different rules on the size of skirts and things like that. You also get a lower legality height. You can bring the car a little bit closer to the ground than you can in just normal open. There's a few other things in terms of changing to allow the cars to run slicks and stuff like that. Now, in terms of determining how the rules are going to work out for your aero package, the first thing that I usually do is I go and read the rules thoroughly and work out my legality volumes. So that's basically where I can put different aero components. So like, for example, there's a legality volume that states how far above the roof of the car you can go with the rear wing, how far rearwards of the rear bar you can go. And those rules changed a little bit for Pro Open class. So I construct a bunch of legality volumes in CAD, computer-aided design, and then I can put aero package within those volumes, and then I can verify against those volumes and see how everything's all working out.
If we're talking about something like the rear wing, you mentioned the rules on how high above the roof line it can be and how far back. I mean, obviously, notwithstanding, at some point it's going to start looking ridiculous. If there was no rule, is it a case of higher and further back just becomes better?
Not always, not always. It depends a little bit on the package. With this particular car and this rule set, we did find going higher and further back was better. That's not always the case. It's often a compromise in terms of height of downforce versus overall drag efficiency. If I was allowed to, I would probably go a little bit further rearwards on this wing. I don't think I'd go any higher though. So even if you're unlimited, you wouldn't just position the wing off into infinity.
From my non-aerodynamic perspective, I would assume that the challenge with a sedan like this Evo is always getting more front-end downforce. I'm guessing you pretty much bolt on a big rear wing, and notwithstanding maybe being inefficient and draggy, it's easy to make downforce at the back, but harder at the front. Is that the case? And if so, how do you deal with it?
Not so much. It's one of those things where once we started to crank the front end and add some of the more interesting concepts we've got on the front end of this car in, we actually just strictly for rear more than anything. Then we started to do more intense development on the rear end of the car. And we found a lot of gains on the rear, on the floor in particular. And a lot of people will probably notice that the rear wing on this is a bit smaller than some of our competitors. That's because the floor is so effective on this car, which makes it quite efficient. We're getting very high trap speeds. I could have gotten a lot more downforce out of the front. Instead, I've elected to get a package that has a slightly better front characteristic, is a little bit more forgiving to set up, so we can run the front a little bit higher. We're not actually on legality at the front, and that way we get still good performance, but we got a little bit more of a window to set the car up in.
Okay, a couple of things to just unpack there. So let's just go back to the rear floor. So with the diffuser at the back of the car, is this sort of a case of you're generating downforce without the drag that you would get by doing it with a larger, more aggressive rear wing?
Not quite.
Not that simple?
No, not that simple. Everything's a balance on these cars. You can't just go infinite drag for a small downforce gain. It doesn't make the car faster. With the diffuser on this car, it does make a bit of drag, but in general, it was more about a case of trying to get very good rear downforce, more than it was just efficiency. The rear wing, once we started to crank the rear wing more and more, and we trialed out some bigger rear wing designs, there's an off-the-shelf one, but we trialed some bigger ones in CFD, and you start to get some negative interactions in certain components in a bigger wing. Obviously, you have a fixed legality box, so you can't quite put it in it. So there's more limits than just the efficiency. But in general, the floor on this car is extremely efficient. It is quite low drag for the amount of downforce it produces, but there's no hard rules here.
I think you mentioned earlier in this chat that the rules state that the floor is open. So I'm guessing by that you're meaning there is no flat floor front to rear?
Yes. So unlike Pro Class, where you're allowed to run a full floor, this car, basically from the front axle line to the rear axle line and between the two chassis rails, it's completely open. It's all as per factory in that. And this is a full car. It's not a space frame or anything like that. It is a factory car. So we have to leave that open per the rules. And that creates a lot of interesting aerodynamic challenges because the airflow on the outer parts of the car, where you can have skirt and floor, is really good. Airflow in the center is actually very difficult to manage. And that's probably been one of the hardest things with still getting this to a good downforce is that central floor region.
Now, obviously, everyone running in the class is under the same rule set, so the playing field is leveled. I don't know if it's possible to give me sort of an idea of this, but if you were legally allowed to run a flat floor instead of the open floor, what sort of percentage improvement in downforce would you expect to see? Are we sort of talking a 5%, 20%, or just not possible to state it like that?
So it varies a little bit where like different cars have different chassis rail widths. And so a car with really narrow chassis rails is actually much closer to a floored car than one with really wide rails. So everyone's on the same rule set, but not everyone's on equal footing there. So that's the first part. The next part is that I think that even if I had to run the standard chassis, so I couldn't cut out of it to make a big diffuser tunnel or anything like that, I think I could pretty easily get an extra 20% if I infilled that floor region. Just
so that's massive.
Yeah, it's pretty big. The biggest thing is the downforce and cornering, because in the cornering condition, the uncontrolled flow in the center of the car has a tendency to move around a lot more. So in the straight line, you can actually control it all right. But the second you get into a corner, it likes to move all over the place. And that's where a flat floor would be much better. So our mid-corner downforce go up quite a lot.
All right. Another point you made is just the front end, the ride height, making the aero package more forgiving. Can you maybe talk about what you mean by forgiving a little bit more?
Yeah. So with an aero package in the car, you can go and have a package that has very high sensitivity to ride height. So basically, you can get a lot of performance at a very specific ride height, but outside that ride height drops away massively. And that's quite a peaky kit, and that can be quite hard to set up. But if you can get that in the window, it's perfect. It's really potent.
But you have to control that ride height very accurately at high speed, low speed, everywhere around the track.
You need really good control. It also means you need really stiff suspension, so your mechanical grip is compromised. So there's a lot of compromises with that approach. Whereas if you go and flatten out the curve, so you have a bit less peak downforce, but you have a slightly more forgiving curve, then you have a car that is maybe a little bit less peak performance, but it's less sensitive on where you have to set up. So if you have a suspension issue and you need to move the car to a different suspension window, you can do that without completely ruining your aero.
Would it be safe to assume as well that a more forgiving aero package like that would be better suited to a novice driver, and something that's very peaky with a very, very narrow setup window would work well with a professional driver?
Yeah, definitely. There's a big factor of that. Obviously, in Pro Open, we are using professional drivers, so that's not a huge consideration for us in that aspect. But yes, if you had an amateur driver, you'd be better off with a smoother curve.
Now, another thing I spied at the start of this is the push taps that you've incorporated into the front splitter, which is something I personally haven't seen at World Time Tap before. This is sort of what we hear about in Formula One, where the drivers go off into the gravel and then say, check the floor, I might have damaged the floor. And that's what the engineers are doing. Can you talk to us about what a pressure tap is and how you're utilizing them?
Yeah, so a pressure tap is basically a sensor that allows you to tell the air pressure at a specific point on the bodywork. This is technology we use in high levels of motorsport, F1, like your higher ends, like Le Mans classes and stuff like that. And it's something that, from my background, I'm used to having that sort of data. So it's kind of hard on these club level cars to actually set up the aero effectively, because you're kind of trying to read it out from a bunch of other suspension sensors instead of
trying to infer rather than directly measure.
Exactly. So I've come up with the help of a colleague, a custom set of boards that allows us to log a bunch of different pressures. We currently only have the front splitter tapped up, but we can measure the pressure at a number of points on there, and we can basically correlate that to where it is on the track and see what the characteristic is like. And that's really useful for measuring things like dropouts and things like that. So let's say you had a car that was porpoising. You might see some weird pressure traces where the splitter is getting close to the ground and then it's dropping out, it's losing all its downforce. You'll actually see that on the pressure taps and it'll come back up. This car, it's been really good because we've been able to see, like, is the aero kit working quite symmetrically? Have we got any damage, anything like that? Honestly, it's been very useful, and the splitter is working quite well. And we're going to go and grab that data afterwards and back correlate it to the CFD, see where we're sitting in that. Because in the CFD, we do mapping of a whole bunch of different conditions. So we have a map of how we would expect the pressures to look on the splitter in different car conditions, so we can check whether or not that's behaving correctly.
In general, how well does the data or the operation of the car stack up with CFD and when you get it out in the real world? Is it pretty close correlation? Or is there always a learning curve?
There's normally a lot of errors between CFD and the real world. There's a lot of things that can be different there. Even at a professional level, correlation is not particularly good. Like if you were off by 10% to CFD from the real car, even in F1, I wouldn't be that surprised. Whereas like compared to a wind tunnel, I would expect a much closer correlation.
Of course, in F1, the wind tunnel testing is highly limited, so CFD becomes the fallback tool.
No.
There's still limitations on CFD as well, aren't there?
There's limitations on both. So I'd say wind tunnel is still your primary tool in the high-level motorsport for working out your pressure tap mapping. I think that at this level, if I was within 10% of my pressure taps CFD, I'd be over the moon. The main thing I'm looking for is more than the absolute values. I'm looking for the characteristics. I'm looking for if CFD is showing the downforce going up with ride height, but the taps on the real thing is showing it going down, that's bad. If I'm seeing no stall or separation and dropouts CFD, but I am seeing them in real life, also bad. That's what I'm really looking for. I'm not looking for like, can I get this within 3% of CFD? Because it's not realistic, and it's also just not that useful.
It doesn't really matter.
Yeah, it doesn't matter. You care about the track performance, and you care about being able to predict the direction of that track performance more than you care about being able to predict the absolute magnitude of that track performance.
Let's just come back to the development of a package for a specific car. So we've sort of talked about the rule set and how you go about that, and you've mentioned CFD. Once you've actually got the parts designed and you're happy in CFD, they're doing exactly what you expect, how do you then go about taking those from the virtual world and actually ending up with physical products that can be physically bolted to the car?
So the way we do it, the development package like this is, we 3D scan the whole car. We scan all the parts that we think we're going to mount to and any clash risks. And then we go design all the parts in CFD. We do a bunch of iterations in CFD. Then once we've done all that, we go and we send the CAD files over to the manufacturer. So in our case, Sydney Composites did this Aerodynamics package. And they'll basically take those files, they'll convert them into molds for carbon work, and then they'll produce the carbon work and they'll fit it to the car. One of the things that's been really good with this car is that we've had a good set of 3D scans on it. We've got a whole bunch of different scans, different levels of the car together and apart. And so we've been able to do a lot of parts in this car that have just been scan, go and get them manufactured, do the trim lines even in CAD, and they all just fit up. The fit up on this car has gone really well. Everything fits exactly per the CAD model. And even things like the front guard infills, those are 3D printed cores with a wrapped outside, and they just fit straight in perfectly.
Look, Kyle, great to get some insight into how a package at this level works. And of course, you do work at the club level as well, not necessarily top end. If people are interested in reaching out and getting you to do some consultation work for them, how are they best to do so?
Yep, so the best way to do so is probably to either try my email, kyle@jkfaero.com, or you can go to the JKF Aero website. And basically there's contact form to fill that out. We do have a fair bit of a waiting list. It's not going to be a straight away thing, but if you drop your details there, we will eventually get back to you.
Perfect. Thanks for your time, Kyle.
Yeah, no problem. Thank you.